If May 3rd is a Thursday, what day of the week is May 29th? Well, let's make a little calendar here. We have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. And they have said that Thursday is the 3rd. So let's just jump ahead 1 week at a time. So 10th, 17th, 24th, and then the 31st. And they want May 29th, so it'd be 2 days behind. So that's 29 there, and that corresponds to a Tuesday. How many integers are there between negative 11 and root of negative 11 and root of 29? Well, let's see. So we've got these two numbers. Now the root of negative 11 is minus 3.3 approximately, and the root of 29 is 5.4 approximately. So it looks like the integers between those two would be minus 3, minus 2, minus 1, 0, then 1, 2, 3, 4, and 5. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 integers. In rectangle ABCD, the two diagonals are intersecting at E. The ratio of AED to DEC is 7:11. What is the measure of BDC? Okay, so this label it theta, and I'll label this gamma. And because of the symmetry of this diagram, those two are equal, so that means that's an equilateral triangle based on the properties that if two sides are equal. Sorry, not equilateral. Isosceles. That's what I meant to say. Let me just write it out. Isosceles. All right, so we are told that theta over... well, we need one more. This angle in here, I'll call alpha. So we're told that theta over alpha is 7/11. So that basically, if you isolate for one of them, theta would be 7/11 times alpha. And then theta plus alpha, that is going to be 180 since they occupy one line. And therefore, we have 7/11 alpha plus alpha is 180. And that's going to be, let's see, if we get common denominator, it'll be 7 alpha plus 11 alpha, so 18 alpha. And then this will be 11 times 180. And then if you divide through, you get 11 times 10, so alpha would be 110. Okay, and then in the triangle, DEC, the sum of the angles will add up to 180. And therefore that's 2 gamma plus alpha, which is 110, is 180. That means 2 gamma is 70, then gamma is 35. 35 is the answer that they're looking for. The sequence of real numbers 80, XYZ, 3125 is a geometric sequence. What is the value of y? All right, so if it's a geometric sequence, that means that x over 80 will be the same as y over x, will be equal to z over y, will be equal to 3125 over z. Okay, so let's see here, what equations can we get from these guys? We get z squared is equal to 3125 times y. From these two, we get x squared is equal to 80y. And then from the middle two, we would get y squared is equal to x times z. Okay, so we are trying to find what? The value of y. Okay, so let's make everything in terms of y. That would mean x is root of 80y, and z is the root of 3125y. So plug that in here, 80y, 3125y, and then if we multiply that, that's going to be a big number, 250000 y squared. And then that would be 500y. Divide through by y, and we get y is equal to 500. The ordered pair of integers xy, x between -5 and 5 inclusive, y also the same. How many such pairs satisfy x squared plus y squared is between 9 and 25 inclusive? All right. Well, there's several ways of doing this. One way is to look at it with the equation of the circle, right? Where you have one circle that has a radius of 3 and another circle that has a radius of 5. And these are the formulas for each. One circle has the formula x squared plus y squared is 3 squared, which is 9. And the other circle has the formula x squared plus y squared is 5 squared, which is 25. And then you want to basically look at the points in between. That's one way of doing it. Another way is just sort of the manual way, which is kind of just listing the possibilities. And because there's not that many, I'll just do it manually. So let's see what we get. So let me just make the table first, and then I'll explain it. All right, so what am I doing here? Okay, so when x is, we're just going to go through the choices since there's not that many. No, -5 to 5. So first I'll do 0, then I'll do the positive ones, and then the negative ones would be about pretty much the same, I think, it would, because there's symmetry in this diagram, symmetry in the equations. Okay, let's see what we get. When x is 0, this inequality becomes basically 9 is less than or equal to y squared less than or equal to 25, correct? So then that means y can be either plus or minus 3, plus or minus 4, or plus or minus 5. I ran out of space there. So that's going to be how many pairs? 1, 2, 3, 4, 5, 6 pairs. Got it? And similarly, when we have 1 for x, the equation becomes, let's see, if it's 1, it would be 8 less than or equal to y squared less than or equal to 24. So then that would be plus or minus 3 and plus or minus 4. So that would give me 1, 2, 3, 4 pairs. And then keep on going here. When x is 2, the equation becomes 5 less than or equal to y squared less than or equal to 21. And then now, again, plus or minus 3, plus or minus 4 pairs. When x is 3, the equation becomes 0 and 16. So then we'd have a lot. We'd have actually 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. When x is 4, this becomes minus 7 and 9, I believe. So then that's going to be 0 plus or minus 1 plus or minus 2 plus or minus 3. So that's 7. And then finally, the last one, that would give me, I guess, just 0. And that's just 1. So this is, let's see here, 10 plus 8, 18, 25. And therefore, these guys are also going to be 25 because of the symmetry. I basically, I did these ones, and then if you do the negative ones, you're basically doing this side, which would be pretty much the same, and you guys can do that. So the total would be the 6, that 25, and that 25, and that is 56 total pairs. In square ABCDM is the midpoint of AD and is the midpoint of BC. Circle is drawn, so that is tangent to both AN and MC. If AB is 2, what is the area of the circle? Okay. Well, the first thing I'd like to do is draw one tangent line like that. Hopefully that is accurate. It's okay. Not the best line, but you understand. Basically where the tangents touch. All right, so what I think we can do is put this on a coordinate axis. And that may help like that. So this is sort of the origin right here. D is the origin. Okay, let's see what we get. Based on the information in the question, it seems to me that the coordinates of M are 0, 1, and the coordinates of C are 2, 0. So we basically want the line MC, that equation, and you guys know how to do that, right? First you figure out the slope, and then that would be minus a half, and then therefore that would be y equals mx plus b plus, and then when you plug in one of these points, let's just plug in 0, 1, that would basically give me b equals 1. So the line MC has the equation y is equal to minus 1/2 x plus 1. Okay, so that's the first part. Now the second part is the red line. That red line I drew in the circle, that is a tangent, right? Because it's tangent because it's well, it even says that in the question. That's why it's tangent. It's tangent to both AN and MC. So its slope, if we call it M2, would be the negative reciprocal of negative a half, which is 2. So that equation would be y is equal to 2x plus b. And this point right here, this point right there, is on that red line, and it's also on MC. So that point, whatever you want to call it, has the coordinates x, y, but y is that right here, because that's the equation of that line. So the coordinate would be of this form. Yeah. And because of the symmetry of the diagram, the center of the circle would be on that red line. Got it? So since the center of the circle is on the red line, the center of the circle is the same as the center of the square. So that's the point 1, 1. So the 1, 1 would satisfy this equation. So that would mean that b would be equal to negative 1. Yeah, so the equation of the red line would be y is equal to 2x minus 1. And then this point satisfies it, so we can sub that into there. And when we do, we get minus 1/2 x plus 1 is equal to 2x minus 1. So that means 2 is equal to 2.5x, and then the x would be therefore equal to 0.8. And we sub it back into the equation, this one, either one actually, that one or this one, you would get y is equal to 0.6. Okay, so that is what? That is the coordinate of that point that I have an arrow. So now we have to figure out the radius. The radius would be the center, we can call it O, to this point, which we can call P. So you guys see it. So the radius is basically OP. And that's basically going to involve the distance formula. The point O is 1, 1, and the point P is 0.8 and 0.6. Got it? So then we find out the distance. The distance formula, r squared, would be 1 minus 0.8 squared plus 1 minus 0.6 squared. And therefore that looks to me like 0.04 plus 0.16, and that's 0.2. So therefore pi r squared, which is the what we're trying to figure out, the area of the circle, would be pi times 0.2, and that can be written as pi over 5. A nickel is a coin worth 5 cents, dime is a coin worth 10 cents, and a quarter is a coin worth 25 cents. Rolo has X nickels, Y dimes, Z quarters. Pat has Y nickels, Z dimes, X quarters. Sarky has Z nickels, X dimes, and Y quarters. None of them have any of the coins. If the total value of the coins is 6,480 cents, how many coins does Pat have? So we have nickels, dimes, and quarters. And we have Rolo, Pat, and Sarky. So this is X, Y, Z. This is Y, Z, X. And this is Z, X, and Y. So the total, which is what they're talking about, the value of all their coins, that would be, let's see here, 5X plus 10Y plus 25Z plus 5Y plus 10Z plus 25X plus 5Z plus 10X plus 25Y, and all of that equals 6,480. So when you add these all up, you actually get 40x plus 40y plus 40z. And then if you divide through by 40, you just get x plus y plus z is equal to 162. And they're saying, how many coins does Pat have? Well, Pat has x plus y plus z coins. And x plus y plus z is equal to 162. What is the sum of all positive integers less than 1,000 that have only odd digits? So we are choosing from all the positive integers all the way up to 999. So that is our range. But we only want the ones that have odd digits. So let's break this down. First, let's talk about numbers that have only one digit in them. And then we'll talk about numbers with 2 digits. And then finally, we will discuss the ones that have 3 digits. And then in the end, we have to figure out the sum. Right, because that's what they want. Okay, let's see what happens. We're going to try to get a pattern because obviously we can't list all of the numbers. There's way too many of them. So one digit, 1, 3, 5, 7, and 9. Those are the only one-digit numbers that have only odd digits, correct? And the sum, since there's so few, we can just add it up manually, is 25. Okay, so no real pattern there, not much to work with. Now let's talk about 2-digit numbers. So we have 11, 13, 15, 17, 19. We have 20, 31, 33, 35, 37, 39. We have 51, 53, 55, 57, 59. 71, 73, 75, 77, 79. 91, 93, 95, 97, and 99. Okay, I think that covers it. Now let's figure out the sums. This sum is 75. Those 5 numbers, 175. That is 275. And that is 375. And that sum is 475. So the grand total of all these guys is 1375. Now, I was looking at this and thinking, is there some sort of a pattern? And I noticed that this 75 is basically 5 times 15. 5 times the middle number. This is 5 times 35. And so on. I believe that's 5 times 55 and so on. So this number, this grand total, I said, well, is there some correlation between the middle of all of those guys, which would be 55, and there is. It's 55 times 25. Now 25 represents how many digits, how many numbers we have. Like all these guys, there's 25 of them. Here there is 5. Here there's 25. So it's similar here. You took the middle number and multiply it by how many numbers you have. Here you take the middle number and multiply it by how many numbers we have. Got it? So I think that's how we're going to figure out the sum of the 3-digit numbers. Now there's a lot to list, so I'm not going to list them all. But there's the ones that start with 1, the ones that start with 3, 5, and 7, and 9. Correct? And the ones that start with 1, it would be like 1, let me think about this. 1, 1, 1, 1, 1. The first ones would have 1 as the second digit, 3 as the second digit for the next list, and then so on. And then for each there'd be 5. So 111, 113, 115, 117, 119, 131, 133, 135. I'm listing these for a reason. I just want you to understand how to make the list first. And I'm not saying you have to make all of them, but at least understand how at least one of these would work. 157, 159, 171, 173, 175, 177, 179, 191, 193, 195, 197, 199. So that just covers these guys, the ones that begin with 1. Now, I'm interested in the middle. So the middle looks like it would probably be the ones that begin with 5. And there's going to be a whole bunch of them. and I'm looking for the middle one, this guy right here. So let's see what I get. I get 5. All of them begin with 5. And very similar, it would be 5, 1, 1, 5, 3, 5, 5, 5, 7, 5, 9. So it would be 5, 1, 3, 5, 1, 5, 5, 1, 7, 5, 1, 9, 5, 3, 1, 5, 3, 3, 5, 3, 5, 5, 3, 7, 5, 3, 9. And the next row is where we get the middle one. 5, 5, 1, 5, 5, 3, and 5, 5, 5. So that's the middle number, 5, 5, 5, 7, and 5, 5, 9. And you guys get the point. So the middle number is very important because we multiply that by how many total numbers there are, we'll get the sum. And the total numbers, let's see, with the ones there was 1, 2, 3, 4, 5, 25. So there's going to be 25 that begin with the 1, 25 that begin with the 3, and so on. So it looks to me that the grand total of the 3-digit guys is 125. So that's what we'd multiply this by. And I'm pretty sure that is how we do it, and that's 69375. So the grand total, the grand sum, would be this 25, this 1375, and this 69375. So we'll just put it in the middle here. 5 plus 1375 plus 69375, and that would be 70775. A sphere with center O is cut into 2 hemispheres, each of which is placed on its circular base. Radii OC and OD are drawn in the 2 hemispheres, each perpendicular to the base. Point A is on OC, so that OA is 1/3 of OC, and point B is on OD, so that OB is 2/3 of OD. Each hemisphere, a plane parallel to the base, cuts the sphere along a circular cross-section of the hemisphere. The plane cutting the hemisphere with radius OC passes through A, and the plane cutting the hemisphere with radius OD passes through B. Each cross-section forms the base of a cone with its vertex at O. What is the ratio of the volume of the cone with A on its base to the volume of the cone with B on its base? All right. So let's try to keep the wording in the question, but eventually I'm going to need a lot more space. So first let's set this up here. I'm going to actually give the radius a value because I don't want to work with letters the whole question. It'll make things a little too abstract. Let's just give it a value. I don't think it matters because in the end you're looking at a ratio, so the radius will cancel out. And they've been very nice and given us the formula. So what we're really looking at is the following. 1/3 pi, the radius of A squared times the height of A, over 1/3 pi, the radius of B squared, over the height of B. Now the 1/3 and the pi's cancel. So that's just going to leave me with the radius and the heights. Now let's just figure out the height first. The height, let's see here. The height for the first guy, I believe, is going to be the height of A here. Let me just write it properly. Is the distance from O to A. And OA, they tell me, is 1/3 of OC. So OA is 1/3 of OC. OC is the radius. So that's just 1/3 of 9. So 9/3. So that's 3. Okay. So this becomes RA squared times 3. And then I'll have RB squared, and I have to figure out HB. In a very similar way, in the other diagram, the radius is also 9, and that represents OD. And for that one, OB, which is the height there, height of B, is OB, and that's 2/3 of OD, so 2/3 of 9, and that looks to me like 6. So this is 6. So in the end, all we have is RA squared, the radius of A squared, over 2 times the radius of B squared. that is what we would need to figure out. If we can figure that out, we're all done. Okay, so let's see how we do that. Now I'm definitely going to need space. Okay, so let's think about this here. I'm going to draw a line. I'm just trying to think where. The line, I will draw it from A to the edge there, like that. And I will call the point where it touches E. And from O to E is the radius of the sphere, correct? Because the radius of a sphere is basically the center of the sphere to any point on the edge. So OC is also the radius, and so on. Okay, and then in that triangle, EAO, it's a right triangle. So that means that E to A squared plus O to A squared would be the same as EO squared, correct? So that means that EA, do we have any of these values here? Let's see here. EA, I don't think we do. That actually would be the radius of A. This guy is the radius of A in terms of what we are looking for. OA we know, that's up here. I got that well, I mean, I gave it a value. EO is the radius of the sphere, and that had previously been called 9. Okay, so that means RA squared would be 81 minus 9, which is 72. All right, so that's actually very good, very helpful. And then very similarly, we'll do the same kind of thing over here. Draw a line from B to the end. Let's try that again here. It didn't show up. We're going to draw a line from B to the edge. There we go, like that. And then call that whatever. That point you can call it F, where it touches. In a very similar way, we have this time OF is the radius, which is 9. Yeah. And not that it matters, but I just wanted to compare that to OD, which is also 9. Okay, so then again in triangle FBO this time, using Pythagoras, FB squared plus BO squared will be the same as OF squared, right? So FB is what we're trying to figure out, and that's the radius of the B. Yeah, the radius of the, I guess, the cone that has B as its the center of the base. And then BO, I think we figured that out somewhere. We just got to find it. Did we? Oh yeah, right here. It's 6. And then OF is the radius of the sphere, the entire sphere, so that's 9. So that means RB squared is 81 minus 36 is what, 72? So that's 72. No, sorry. Is it 81 minus? Yeah, 81 minus 36 is not 72. Jeez. It's 45. I'm thinking over here. I've got that 72 stuck in my head. Okay, so now we can go back to here. Yeah, so that's just going to be RA squared, which is 72, over 2 times RB squared, which is 45. So that's 72 over 90. And in lowest terms, I believe that's 4 over 5.